Hi, my name is Kate Berry from the University of Texas at Austin, and welcome to this video where I model how to solve multi-step total and equal groups problems in our multi-step word problem intervention with total, difference, change, and equal groups problems. We have 5 different components of our multi-step word problem intervention with total, difference, change, and equal groups problems. First, captain cards, then equation quest, then buccaneer problems, ship shape sorting, and our Jolly Roger review. Our word problems are primarily featured during our guided practice activity of the buccaneer problems and our independent practice activity of Jolly Roger review. For the focus of this video, I'm going to tailor my studying up and solving of multi-step total and equal groups problems with our buccaneer problems, because this is when we are setting up and solving word problems in a guided practice setting. Let's take a look at the materials. First, you'll need your multi-step word problem mat version 2 that has our total and equal groups poster. You'll need your buccaneer problem worksheet, a pencil, and your What Do You Ask Yourself poster, which we use to help students differentiate between the 4 schemas using questioning and gesturing. So again, we have 4 different types of multi-step word problems: total difference, total and equal groups, which is the focus of this video, equal groups and equal groups, as well as equal groups total, and equal groups difference. We have videos on all of these different multi-step variations, so please take the opportunity to check those videos out. But I do want to mention that when I did an inventory of all the different word problems that we see at grades 4 and grades 5, we primarily see these different schema combinations for multi-step word problems, which is why we chose to focus on these 4 different schema combinations in our word problem intervention. Here again, this video is focusing on total and equal groups problems. This is a zoom in of our multi-step word problem intervention version 2, and here you can see our 2 word problem equations that students will use when they are seeing and solving a total and equal groups problem. Here, our first equation is open parentheses P1 plus P2 divided by GR is the same as blank. Here you'll see that it's almost like the total schema and the equal group schema got married and are pushed together. We teach students to use our first equation when we have a combined amount and then when we have an equal groups problem with a known product. Our second equation, open parentheses GR times N, close parentheses plus P2 is the same as blank. Again, here we see the equal group schema and the total schema coming together in one equation. First, we will have this equation when students are multiplying and when we have an unknown product, and then when they add. So we're going to take a look at 2 word problem examples. The first one using our first equation when we have a combined amount and then we have a known product, and then our second equation when we have an unknown product and we have a combined amount. So let's take a look. Again, here these are the equations with which we're working. So let's take a look at our first word problem example here. We always want to check for a table or a graph. I do not see a table or a graph, but if I did, I would number it. So I'm going to go ahead and write my attack strategy on the side here as a guide to help me work through this word problem. So now that we've written our attack strategy on the side of our page here, let's go ahead and get started solving our problem. Our first U stands for understand by reading, so let's read our problem. It says, Jordan's mom had 6 cups of chocolate cereal and 6 cups of granola cereal in a box. His mom poured an equal amount of cereal into 2 different bowls. How many cups of cereal were in each bowl? So here I check off my first U. I've understood, I've read the problem. Now I'm going to move to my second U, which stands for underline the label. Most of the time the label is in the question sentence, so let's read our question. It says, how many cups of cereal were in each bowl? Here I'm talking about cups of cereal, so I'm going to go ahead and underline that in my question sentence and put a check mark next to our U. Now you can always check for irrelevant information during this U step, but I also like to check for irrelevant information during our first P, which stands for put parentheses around needed numbers, because any number that's not needed I can cross out at that time. So now we're going to scan our numbers and put parentheses around any numbers talking about or related to cups of cereal. So my first number is 6. This is talking about cups of chocolate cereal. So that is related to my label. So I'm going to put the number and the word in parentheses and continue scanning. My next number is 6. That's talking about cups of granola cereal. So I'm going to go ahead and put parentheses around that and continue scanning. My last number is 2. 2 is about different bowls. That's not about cups of cereal, but I'm putting the cereal into the bowls. So while it's not about cups of cereal, it is related, and we do need that number 2 because we're putting the cereal in the bowls. So I'm going to go ahead and put parentheses around 2 different bowls and check off my first P. Now my second P stands for put the numbers in order. When we were working with single step problems, we only needed to put a 1 above our numbers. But now that we have problems where there are multiple steps, we have to think extra hard about what's happening first and what's happening second. So let's reread our problem. It says Jordan's mom had 6 cups of chocolate cereal and 6 cups of granola cereal in a box. His mom poured an equal amount of cereal into 2 different bowls. How many cups of cereal were in each bowl? So I need to figure out how many cups of cereal we have first, and then we need to figure out how many cups of cereal are in each bowl. So here I'm going to put a 1 above the cups of chocolate cereal and the cups of granola cereal because I know that I'm dealing with the cups of cereal first, and then after I have the cups of cereal, I'm going to put them into the bowls. So I'm going to put a 2 above this set of parentheses, 2 different bowls. Now I have put my numbers in order and put parentheses around my needed numbers. I can move to my first S, which stands for schemas. So here I have my What Do You Ask Yourself poster. So I'm going to read this to help me figure out what is happening in my story. So are parts put together for a total? Are 2 amounts compared for a difference? Is there a starting amount that increases or decreases to a new amount? Or do I have groups with an equal number in each group? A lot of times it's helpful for students when you break up our word problem story into sentences. So that's what I'm going to do now. It says Jordan's mom had 6 cups of chocolate cereal and 6 cups of granola cereal in a box. So here we're putting together the cereal. So that's what's happening first. I have chocolate cereal and I have granola cereal, and I need to figure out the total amount of cereal before I put that into the bowls. So I'm going to put a 1-T to let me know that for my first step, it's a total schema because I'm putting together the cups of chocolate cereal and the cups of granola cereal. Now I have to think about what's happening second. It says his mom poured an equal amount of cereal into 2 different bowls. How many cups of cereal were in each bowl? Well, here I'm sharing equally. And if I'm sharing equally, I know that I have an equal groups problem where I have a known product. I know my total cups of cereal and I'm sharing it equally into bowls. So if I have an equal groups problem, like I do here, with a known product, and I want to know the number in each group, I'm going to put a 2 and an EG for equal groups. Now all I need to do before I solve is look at my poster here and think about which equation I'm using. Here I can see that whatever is in parentheses here is part 1 plus part 2, which tells me that first I'm combining. In the second equation, it's GR times N, the groups times the number in each group, which would tell me that I'm multiplying and have an unknown product. Here, I know that my first step is total. I know that the first thing I'm doing is combining, so I know that I'm going to use this first equation because I see P1 plus P2 in parentheses, and I'm combining before I'm sharing. So I'm going to go ahead and write my first equation. Now, if I were going to multiply to find a product first and then add, I would know that I would use my second equation. But because I am combining and then finding the number in each group, I'm going to use our first equation here. Open parentheses, part 1 plus part 2, close parentheses, divided by the groups is the same as blank. And we use divided by the groups as a little bit of a way to understand that this is an equal groups example where we have a known product. So now I have figured out my schema, I'm ready to solve, and all I need to do is plug in my numbers. So I have a 1 and a 1 here. So I know I have 6 cups of chocolate cereal, 6 cups of granola cereal, and I know that I'm sharing them equally into 2 different bowls. I always like to check off my numbers to let me know that I'm finished with those steps. And now all I need to do is add my parentheses and my signs. So we teach students about the order of operations. We teach them whatever we do in parentheses is what comes first. So here, what I see in parentheses is 6 plus 6, so I know that I'm going to do that math first. 6 plus 6 gives us a sum of 12, and now all I need to do is bring down divided by 2 is the same as blank. I know 12 divided by 2 is the same as 6. Some of our friends might need a multiplication table. That's perfectly okay. You can have kids use the multiplication table or do the inverse and say what times 2 gives us 12. But I know here I have 6 as my quotient, and I need to look to see what my label is because we don't want to make that number lonely. And our label is cups of cereal. So I have my number answer and label answer, and I've solved it. The very last thing I need to do is check for reasonableness. I need to make sure first that my number answer makes sense, and second that my label answer makes sense. If I have 6 cups of chocolate cereal and 6 cups of granola cereal and I'm combining those, it would make sense that my sum was 12. And then if I have 12 and I'm putting them equally in 2 different bowls, it would make sense that my number in each group would be 6. So I feel pretty confident that my number answer makes sense. The last thing to do is check our label. Our label is cups of cereal, and this matches what we underline. You also can check off your 1-T and 2-EG if you want. So here's an example of a total and equal groups problem because we're combining an amount and then we're sharing an amount equally among the groups. In the next word problem, I will model an example where we're using our second equation. I'll see you shortly. Now let's take a look at an example of a multi-step total and equal groups problem where we're using our second equation here. First, we always want to check for a table or a graph. I don't see a table or a graph, but if I did, I would number it. I'm going to go ahead and write UPS check on the side here. And I'm going to go ahead and work with my first U and understand by reading the problem. This says Darren bought 5 pizzas that were $10 each. He also bought breadsticks for $9. What was the total amount Darren paid for the pizza and breadsticks? I feel like I've understood the problem. I'm going to check off my first U. Now I'm going to underline my label. I mostly can find my label in the question sentence, so I'm going to reread that. It says, what was the total amount Darren paid for the pizza and breadsticks? Here we're talking about payment and amount. I know we're talking about money. We don't write 5 paid as an answer, so I'm going to underline paid and I'm going to write a $sign under it to remind me that I'm talking about money. Now, if your students were confused, you could also point them to our numbers, which have $signs in front of them, which is going to be a clear indication that we're talking about money. So I'm going to put a check mark next to my second U and move on to my first P. My first P says put parentheses around needed numbers, so I'm going to scan my numbers and make sure they're talking about or related to payments. So my first number is 5. Well, 5's about pizzas. That's not about money, but I'm spending money on the pizzas. So I'm going to put parentheses around 5 pizzas and then scan. My next number is 10. That's about dollars. I know I need that. So I'm going to put that in parentheses. I'm going to keep going. My next number is 9. That's also about dollars. So I'm going to put that in parentheses. Here I have put all my numbers in parentheses. I'm ready to move to my second P. My second P says put our numbers in order. When we were talking about single step problems, we just had to put a 1 above our numbers. But now that we're working with multi-step problems, we have to think hard about what's happening first in the problem and put a 1 above those numbers. And then we have to think about what's happening second in the problem and put a 2 above those numbers. So let's read our problem again so we can really think about what's happening. It says Darren bought 5 pizzas that were $10 each. He also bought breadsticks for $9. What was the total amount Darren paid for the pizza and breadsticks? So first I need to figure out how much money Darren spent on pizza. He bought 5 pizzas and each of those pizzas were $10. So I'm going to put a 1 above these 2 numbers here because those are going to help me figure out how much money Darren spent on pizzas. But he also bought breadsticks, and that's what's happening second. We have to figure out the total amount he spent on the pizza and the breadsticks. So it's kind of hard to see here with our 2 being blocked with these parentheses, but you can see here that we're putting a 2 above breadsticks. I'm actually going to get my little handy wipe here to make it a little bit neater for you to be able to see that we have a 2 above breadsticks. There we go. Now we can check off our second P because we've put our numbers in order. We know first we have to figure out how much Darren spent on pizza and then combine that with the amount he spent on breadsticks. So now we can move to our first S, which stands for schemas. We teach students to question and gesture as a way to help us figure out which schema we're using. So we can say our parts put together for a total, our 2 amounts compared for a difference, is there a starting amount that increases or decreases to a new amount, or do we have groups with an equal number in each group? First, I need to figure out how much money Darren spent on pizzas. I know he had 5 pizzas and each pizza cost $10. So here I know that I have groups, which is my pizzas, and the number in each group, which is the cost of each pizza. So I'm going to put a 1 in an EG because I know first I'm dealing with an equal groups problem where I have to find the product. I have to find the total amount that Darren spent on pizzas. After I know how much money Darren spent on pizzas, I have to combine that with breadsticks because it says what was the total amount Darren paid for pizza and breadsticks. So I know my second schema is going to be total because I'm combining the amount of money Darren spent on pizza with the amount of money Darren spent on breadsticks. I'm not quite finished though. I now need to figure out which schema equation I'm using. So here I'm going to look at my total and equal groups poster on my multi-step word problem mat version 2. So my first step is the equal groups step. So here I'm going to look. My first equation has the total schema first, and my second equation has the equal group schema first. So I know I'm going to use my second equation because the first thing I'm doing is figuring out how much money Darren spent on pizzas, and I know my first schema is equal groups, so I'm going to use my second equation. So I'm going to write GR times N, close parentheses, open parentheses, GR times N. I'm going to make this look a little bit more like a time sign, plus part 2 is the same as blank. Now I can check off my first S because I know that I have finished that step and I've written my equation. All I have left to do is plug in our numbers. So here my GR, we said we have 5 pizzas. That's my number of groups. I'm going to check that off. My number in each group are the $10 each pizza costs. My part 2 are the 9 breadsticks. I'm going to check that off, and I'm going to check that off. Now all I need to do here is bring down my parentheses and my signs. We teach students about the order of operations. We teach them whatever is in parentheses is what we do first. So here, 5 times 10, that's easy math. 5 times 10 is 50. Now I need to bring down my plus 9, and this is going to give me 59. That was nice. We had easy math in this word problem. Here I have my number answer, but that number is going to get lonely. It needs a buddy. Here I can look to see what I underlined. I underlined paid, but I wrote a dollar sign next to it. So I'm going to put a dollar sign on the left. You also could have students write $59. Now I have solved the problem. The last thing to do is check for reasonableness. So let's check our number answer first. 5 times 10 is 50. I know that makes sense, and that's going to give me the amount of money that Darren spent on the pizzas. And then I have to add that to the amount of money Darren spent on the breadsticks to find the total amount Darren paid. 50 plus 9, that's what he spent on the breadsticks, gives me a sum of 59. That makes a lot of sense. I'm going to check off my first check mark. The last thing to do is check my label. Here my label is dollars, and this matches what I underlined, so I'm good to go. Great job solving this multi-step equal groups and total problem. Thank you so much for taking the opportunity to view this video where I modeled how to set up and solve 2 different variations of our multi-step total and equal groups problems. I'd like to take a moment to thank the Institute of Education Sciences, the University of Texas at Austin, and the Meadows Center for Preventing Educational Risk. Without their support, this work would not be possible. I look forward to seeing you in the next video.